Hi friends, in this video we are going to discuss about Potier triangle method. This is also called ZPF method. Let's see, in this method the first advantage is that here drop due to XL and drop due to XA separated. This is the main advantage of this method. Hence, ZPF method is also called EMF method plus MMF method. This is the first point. Here, the drops are separated. And in ZPF method, we require OCC characteristics and ZPF characteristics. OCC characteristics plus ZPF characteristics. Then we can find ZPF method voltage regulation. Let's see how we can find the voltage regulation in this method. This is the field current. This is EMF for OCC and voltage for ZPF characteristics. How the OCC characteristics? The OCC characteristics are like this. How the ZPF characteristics? ZPF characteristics are like this. OCC, ZPF, and this is called IFSC. This is for example O. This is for example P. OP. See here, OP is equals to IFSC. What is IFSC? At this, the IFSC is nothing but field current required to compensate. What is that? This is the field current required to compensate drop due to XL and XA, combined field current. But we have to separate this field current. Let's wait. I can separate this field current to XL some part and XA some part. Right? Next one. So now see here how we can find the voltage regulation. See here carefully. This is OP. For example, this is my rated voltage on OCC. Rated voltage on OCC. Take the OP projection here. Take the OP projection here at rated value. OP QR. For example, find this much and take here this much. Only this much. So this is the QR. This QR is exactly equals to OP. This QR and OPs are exactly equal. And next, let's draw the tangent to the OCC. This is the tangent to the OCC, which is called air gap line. We know this. So let's this is the air gap line. Of course, we know that. No need to write here because of clumsiness. I am not writing here. This is my tangent. Now let's see. Take the parallel line to the tangent from R. Listen carefully. Take the parallel line to the tangent from R to intersect at OCC. Up to intersect at OCC. This is the PQRS point S. And combine this S and Q. This is S and Q combined. We have a one triangle. This is exactly not a Potier triangle. Don't assume this is as a Potier triangle. This is not Potier triangle. Be careful. Right. Now let's draw a perpendicular line. Let's draw a perpendicular line from S to the RQ or QR. So let's draw it from here. The perpendicular line, this is the perpendicular line PQRST. PQRST. Now this ST, I said you already about this ST. I given you in ZPF characteristics. See here at rated voltage, this line gives us drop due to XL. Nothing but this ST gives us IAXL. Drop due to XL is nothing but IAXL. This is very important point here. And here the triangle RTS is called Potier triangle. This is called Potier triangle. Potier triangle is a right angle triangle. Potier triangle is a right angle triangle. From this Potier triangle, we can find drop due to XL. Nothing but this is also called Potier reactance drop. What is it? This is a drop due to leakage reactance or Potier reactance drop. Nothing but here XL is also called Potier reactance. Be careful. We have another name for XL because in this Potier triangle we calculated drop due to XL. That's why it is also termed as Potier reactance. Right? Good? Very good, sir. So this is Potier reactance. Once observe the diagram, this OP is equals to RQ. This RQ is equals to RT plus TQ. Nothing but this OP divided, separated. I said you already, drop due to XL and XA separated because here the total field current is separated. In this, the RT is called field current required to compensate drop due to XA. This is the field current required to compensate drop due to XA. And this is the field current required to compensate drop due to XL. This is the main advantage of ZPF method. Here we can say, we can give the answer, the separate drops. That's why this is a well preferable method compared to all methods. Compared to all methods, this is the well preferable method because we are separated the required drops. So, finally, now tell me, sir, how we can find the voltage regulation? First, give me analysis. Right, I am giving you here. First, find the XL drop, IAXL, and find RA. We know that how we can find RA. We know that find RA if it is delta R star I given. So RA drop we can find, and IAXL drop also we can find because Potier triangle is there to find IAXL. Now finally the EMF E is equals to V plus IARA plus JIAXL. This is up to now the EMF is called air gap EMF. I said you already in vector diagram. So the air gap EMF is equals to V plus IRA plus JIAXL. This is our air gap EMF. But this is not required answer. We require the total EMF. We have to add IAXA also. How we can add IAXA? Tell me. We don't know IAXA, but we know the field current required to compensate drop due to IAXA. So let's see here. Actually, this is IFSC. But we want that the field current to compensate EAR. Find this EAR on the diagram. For example, this EAR is this one. For example, this is the EAR I calculated from this. For this corresponding EAR, find the IFR. This is my IFR. But in this IFR, we have RA and XL drop, but there is no XA drop. So find XA drop. How we can find XA? So IFR dash is equals to IFR plus IFXA, the field current required to compensate armature reaction drop. Nothing but this IFR dash is equals to IFR plus IFXA, nothing but RT. So we have to find IFR dash. Tell me, where is my IFR dash? This is somewhat increases. But for example, this is my IFR dash. In this IFR dash, we have RA drop, we have XL drop, and we have XA drop, all the drops. Okay, so for that find the ER dash. For that find the ER dash. This is ER dash. Yeah, IFR dash and ER dash. So this ER dash is equals to V plus IARA plus JIAXL plus JIAXA. All are there in this EMF. Then what, sir? Then find the voltage regulation. ER dash minus V upon V. We can find the voltage regulation directly. This is what the zero power factor method or Potier triangle method. Here Potier triangle is a right angle triangle. Understood? Clear? So here the measured voltage regulation is nearly equals to actual voltage regulation. Measured voltage regulation is nearly equals to actual voltage regulation. And in this method, we can tell you, I can tell you drop due to XL and XA separately. That's why this is a accurate method. This is a accurate method up to now. ZPF method is accurate than EMF and MMFs. Accurate than EMF and MMFs. That's why this is called accurate method. Listen. Clear up to now? This has a maximum advantages. Many advantages. And accurate. And whatever we measured, clarity is there, drop due to XL and XA. That's why ZPF method is equals to EMF method plus MMF method. But here also small negligible there, small negligence. That's why small error is there. What is that? Sir, actually you taken up to this, but why you avoided this part? What is this part? This is also field current, of course. What is this field current? This is the field current required to compensate drop due to, tell me, drop due to saturation. Again, here is a mistake. Saturation is neglected. Again, here is the blunder. What is that? The small drop due to saturation neglected. What is that? PQRST? This is, for example, U. RU is the field current. RU is the field current required to compensate drop due to saturation is not added. Here RA is there, XL is there, XA is there, but saturation is not there. there are also some saturation drop. That is the disadvantage or mistake of ZPF method. Of course, this is accurate even though. But how? Now tell me, what is the remedy for this? The next method, the most accurate method, ASA method. What is that? American Standards Association method is the best method, most accurate method. But if they ask you a question, which of the following is accurate method, then you have to give the answer ZPF method. If they mentioned in the question most accurate method, then ASA method. Many times asked in many competitive exams, if they ask you question which of the following is the accurate method, then ZPF is the accurate method. Are you okay? Listen, right? So let's go for ASA method. This is completely what ZPF method, which is very important for us for theory questions. They may not ask you problem on this question, but theory question, this is very important. Right? Next, let's go for ASA method. ASA method. Let's see how ASA method is there. How ASA method we can find voltage regulation. American Standards Association method is this the final method. In this method, IF is equals to IFR dash plus field current required to compensate drop due to saturation, nothing but vector sum of this field current and saturation field current, nothing but IF is equals to IFR dash plus saturation field current is nothing but UR or RU. So this is IF. Then find corresponding EMF. Find corresponding EMF to IF. Nothing but, for example, if the IF is this one, saturation is added, this is our IF finally. For this IF, find the EMF. For this IF, find the EMF from the vector, from the graph. So this is what our E. This E has the, where is my E? Has the armature resistance drop, leakage reactance drop, armature reactance drop, saturation drop. All the drops. That's why ASA method is most accurate method. Most accurate method is our ASA method. Are you getting or not? This is a perfectly most accurate method. And here voltage regulation is equals to E minus V upon V. Like this we can find our voltage regulation. The measured voltage regulation is exactly equals to the actual voltage regulation. This is what the ASA method. ASA method is nothing but the advanced method for the ZPF. The modified ZPF method is ASA method. ASA method is equals to ZPF method plus saturation. ZPF method plus saturation. Right? Clear? These are the things we learned here. Very, very, very important. The indirect voltage regulation methods. Right? What we saw up to now. Let's see here. Let's see here. Indirect voltage regulation methods. What are those? First one, EMF method or ZS method. Second one, saturated synchronous impedance method. Third one, MMF method. and fourth one ZPF method, and fifth one ASA method. Here total drop due to XL, here total drop due to XL, here total drop due to XA, here total drop due to XL plus XA, here total drop due to all R, XL, XA and saturation also. Of course here R also added, no problem. And this is a voltage regulation measured is very high. Here voltage regulation nearly equal. Here voltage regulation measured is less. Here voltage regulation measured is nearly equal. Here voltage regulation measured is equals to voltage regulation actual. Here nearly equal. Here also the voltage regulation measured is nearly equals to actual. This is the ZPF method is accurate method, and ASA method is most accurate method. But in generally we are using ZPF method. Maximum using is ZPF method. Where we are using maximum in ZPF method only. Right? This is called pessimistic method. This is called optimistic method. The difference between these two is this is belongs to I of SC and this is belongs to I of OC. Like that, the indirect voltage regulation methods is very simple. You can write a chart in one page with all the details. That is, that one page is enough to acquire 1 mark in every competitive exam. Every must and should there is a question from this, right? So this is completely what the voltage regulation methods, indirect voltage regulation methods. Is it okay? Completed? Thank you very much.